right, so in this lesson, I'm going to be explaining density. And I know you've probably already studied density in other science classes, but I just want to make sure we're on the same page. So density enables us to relate mass and volume. Mass tells us how much stuff there is, and volume tells us the amount of space that it takes up. And every substance actually has a unique density. So all ice has a specific density, right? All pieces of lead, whether they're humongous pieces of lead or tiny pieces of lead, will all have a unique density. And we've actually, in our everyday lives, experienced density when we look, for example, at what happens when we take a cup of water and we add ice to it. Okay? Common sense and just experience tells us that the ice is going to float in the water. And the reason why the ice floats in the water is not because the ice has less mass, which people often assume. It's because the ice itself is less dense. So if a substance is less dense, then it will float in something that is more dense. Okay, so let's actually bring some meaning to this concept of density relating mass and volume. So what density tells us, it compares the amount of stuff that a substance has, the mass, how much stuff there is, in a specific volume. So the more mass there is in the smaller space, the more dense it is. You can think of it as more things are packed into a smaller space. Okay? So we're going to get a lot of hands-on experience with this in the lab. I want to work first on some calculations with density. So let's look at some example problems. Example 1 says, what is the density of a piece of metal if the mass of the metal is 562 grams? So this, I'm going to just quickly, because this is a word problem, I'm going to identify all of the information. So this is my mass. And the volume is 14 milliliters. Okay, so this is my volume. So I'm going to calculate my density. I know that the formula for density is mass over volume. Okay, and now I'm going to solve it. So density equals my mass, which is 562 grams, divided by my volume, which is 14 milliliters. Okay, so I'm going to take my calculator, I'm going to take 562, and I'm going to divide by 14, and I get, unrounded, 40.143 ... So this is a case where we actually need to look at sig figs or decimal places in calculations. So since the last step that I did was to divide, my final answer, I'm going to round it to the fewest number of sig figs. So 562, because there isn't a decimal present, I'm going to have 1, 2, 3 sig figs there. 14 has 1, 2 sig figs. So my final answer needs to have 2 significant figures. Okay, so 1, 2. So this creates a little bit of a tricky situation because this is going to round to 40. But if I just write 40, that's only 1 significant figure because I'm counting sig figs from right to left, and I can't count that 0. A great way to avoid that, I want to be counting from left to right to include the 4 and the 0 as significant figures. I'm going to actually just put a decimal point there. And I can actually just put that decimal point, and that tells me that the 4 and the 0 are significant. So I dealt with sig figs, now I have to deal with units. Notice my units are simply grams divided by milliliters. So my units for density are grams per milliliter, and that's my answer. All right, let's look at the next problem. An object has a mass of 3.15 ounces. Okay, so that is my mass. I'm going to identify that mass. When it is submerged in a graduated cylinder, so in my brain, there are a lot of words, so I'm going to draw this out. I have a graduated cylinder. Okay. Initially containing 325.2 milliliters of water. So this graduated cylinder has water in it already. And the volume of that water is 325.2 milliliters. Okay? When this object is dropped into that water, the water is going to rise up. Water is going to be displaced, and it rises to 442.5 milliliters. The only reason why that water rose was because of that object. So that object, its volume is causing that water to be displaced. So to find the volume of the object, all I have to do is take that final volume, 442.5, and I have to subtract it by the initial volume of the water, because that difference, which is 117.3 milliliters, that volume is the volume of my object. So this problem does not directly give you the volume, it wants you to figure it out, which we can with this process called water displacement. So now all I need to do is plug in my givens. I know my mass is 3.17 ounces. Well, here's the problem. It wants a density that's in grams per milliliter. So not only did I not directly give you your volume, I made you solve for it, but I need to convert 3.15 ounces into grams. Now, in this problem, I did give you these conversion factors. I gave you the fact that 1 pound is 454 grams, and I gave you the fact that 1 pound is 16 ounces. So notice, I don't give you directly the relationship between ounces and grams. So I'm gonna plot up here what I'm gonna do. So I'm gonna start in ounces. I'm gonna first get into pounds. Then I'm gonna go from pounds, and I'm gonna get into grams. All right, so I'm gonna get out of ounces by putting it on the bottom. I'm gonna get into pounds up top. Now that I'm in pounds, I'm gonna get out of pounds, and I'm gonna get into grams. And I have all of these relationships. I know that 1 pound is 16 ounces, and I know that 1 pound is 454 grams. So I'm gonna take 3.15, I'm gonna divide, because it's in the denominator, by 16, and then I'm gonna multiply by 454. And I get 89.38125. Now, I'm not going to round this, because when you're rounding in a problem, you only want to do it at the very end. So right now, I've got 89.381 grams for my mass, and I've got 117.3 milliliters for my volume. And so I can now plug all of that in to my density formula. Density equals my mass, 89.381, divided by 117.3. Grams are the units for my mass. Milliliters are the units for my volume. So when I then divide, I get 0.76199. I gotta figure out rounding. So this is a little bit tricky, but let's do it. In this step here, when I'm finding my volume, 117.3, I get that by subtracting. So I need to use whatever value I get by rounding to the fewest number of decimal places. Well, the good news, and I made this problem kind of easy, the fewest number of decimal places here is that 10th place right there, 1 decimal place. So this actually, 117.3, is what I should actually be using when I'm considering my final answer, the rounding for that. So 117.3 is good. Then I look at the mass. I start with 3.15 ounces, and I divided that and multiply that to get my answer. Now, I didn't round the final answer, but this answer actually should not be a total of 5 sig figs. It technically should be just 3 sig figs, because that was the original mass I gave you. So this should be 3 sig figs. This one down here, I had said was good, but since my final step is dividing, I'm not using decimal places now. I'm using sig figs. So 117.4 has 4 sig figs. So my final answer, because I'm dividing, should be based on the fewest number of sig figs. Well, 3 sig figs is the fewest number of significant figures. So 1, 2, 3. My final answer is 0.762. And my units, I have grams divided by milliliters. And that's my answer. All right, so it does get a little bit tricky as far as rounding is concerned. Since I'm subtracting here, I gotta keep in mind what this value should be based on decimal places. Gotta keep in mind what this value should be as far as sig figs are concerned, because I'm multiplying. And then since my final step is dividing, then I'm going to be rounding based on the fewest number of sig figs. We'll get a lot of practice with this because especially this part with the with subtracting tends to trip students up. All right, so this was a tricky problem. I made you do water displacement and I made you do unit conversion. Sorry about that. All right, what if I'm not asking for the density? What if instead I am asking you to solve for volume, for example? So I have my formula for density is mass over volume. So let's plug in what I'm given. So it says if the density of a substance is 0.56 grams per mil. So this is my density. Okay. What is the volume? That's what I'm asking for. If the mass is 3.5 grams. So my density is 0.56. My mass is 3.5 grams. And I'm solving for my volume. Now, a lot of students will just panic and randomly multiply. Whenever you see a situation like this where you have a variable on the bottom, we are now going to be in math mode. So math mode tells us that if you've got this situation here, we need to cross multiply because we need to get this volume, this variable, out of the bottom. So here's what you do. You're going to put the 0.56 over 1, and then we're going to just cross multiply. So I have 0.56 times my volume, which is just 0.56 V. That equals then 3.5 times 1, which is 3.5. And now I can isolate my V. I can get my V by itself by dividing both sides by this 0.56. Get rid of that 0.56. So now, in my calculator, I'm going to take 3.5, and I'm going to divide by 0.56, and I get 6.25. So my volume is 6.25. Okay, I got to figure out units, and I need to figure out significant figures. All I'm doing in this problem is multiplying and dividing, and I'm not manipulating any of the values, so I'm just going to be looking at my givens. 0.56 has 2 sig figs, 3.5 has 2 sig figs. So my final answer needs to have 2 sig figs. So I want to keep the 6 and the 2, which means this is going to round to 6.3. Now, my density, the units for my density were grams per milliliter. Grams are the unit for mass. That's where the grams came from. Over milliliters was the unit for volume. So that tells me, since I'm solving for volume, that my unit for my volume will be milliliters. And that's it. All right, let's look at another situation. Here, I'm saying I give you the density. If the density of liquid mercury is 13.6 grams per milliliter, what is the mass of 35 mils of a sample? Now, notice I don't say what is that the 35 mils, what is that? Is that mass, density, volume? Based on the units, I now expect you to know that if I give you milliliters, that is a measure of volume. So this question has me taking my density and is asking me to find my mass. Now, this is a little bit of a tricky question because if you notice, your units for density are in grams, but the final answer we want is in kilograms. We're not going to worry about that until we've actually solved for our mass in grams first. So I'm going to plug in my values, plug and chug. 13.6 is my density. My mass, we don't know, so I'm going to put an M. I'm going to put that over my volume, which is 35. So in this case, to get M by itself, you can either put this 13.6, I like to just always cross multiply. So 13.6 over 1, and then just cross multiply, right? So M times 1, which is M, equals, and then 13.6 times 35. Now, if you just multiply both sides by 35, you would have gotten the same answer. Totally fine. The answer I get is 476. All right. What are my units? Well, my density is in grams per milliliter. So my volume was in milliliters, check. But my mass that I just solved for was in grams. But the question asks for my mass in kilograms. So I need to convert. I gotta get out of grams. I'm gonna put grams on the bottom and I'm going to get into kilograms. Okay, so if you look back at your table in your workbook, it'll tell you that 1 kilogram is 10 to the third grams. So the final answer that I get, because I'm going to take 476 and divide by 10 to the third, you can either get 0.476 kilograms, or you can get 4.76 times 10 to the negative first kilograms. This is in standard notation. This is in scientific notation. Really quickly, I've got to check sig figs though, because I think I ignored them. 13.6 has 3 sig figs, 35 has 2 sig figs. Uh-oh. So my final answer, if I write it in standard notation, should be 0.48 kilograms. But if I write it in scientific notation, it would be 4.8 times 10 to the negative first kilograms. So whichever floats your boat. All right, let's look at example 5. What volume, so that's what I'm solving for, what volume will 45 grams, so again, I don't tell you if this is density, mass, or volume, but as soon as you see the word grams, the unit grams, we know that this is mass, of an unknown gas occupy if the density of the gas is 2.26 grams per liter. So that is my density. All right, so let's do it. Density equals mass over volume. I know that my density is 2.26 grams per liter. That's something we're going to have to be careful with when we're solving this problem. I know that my mass is 45 grams, and I'm solving for my volume. So again, since your volume is in the denominator, I need to cross multiply. So I'm going to do 2.26 times my volume. So 2.26 times my volume, that equals 45.0 times 1, which is just 45.0. To get volume by itself, I'm going to divide both sides by 2.26. Okay. So in my calculator, I'm going to take 45, divide by 2.26, and I get 19.9 for my volume. 19.9. Okay, I have not considered sig figs yet. I got 19.911. Careful, because my density that I gave you was in grams per liter, which means my mass was in grams. Yay, yes it was. But my volume was in liters. So my answer here is 19.91 liters. But it asks what's the volume in milliliters. So we need to do one more conversion, get out of liters and get into milliliters. So 1 milliliter is 10 to the negative third liters. I get that from the table. So my final answer is 0.01991 Oh, nope, sorry, wrong math. Ignore me. I need to take, I should have said this and then I would have caught myself. I need to take 19.91, and in my head I just multiply by 10 to the negative third. That's wrong. It's in the denominator, so I need to divide. So this then becomes 19,910 milliliters. I need to figure out sig figs though, because I've completely ignored them. So 2.26 has 3 sig figs, 45.0 has 3 sig figs. So I need 1, 2, 3 sig figs. So I end up with an answer of 19,900 milliliters. Or if you want to put this, so that's standard notation. If you want scientific notation, 1, 2, 3, 4. So you have 1.99 times 10 to the 4th milliliters. So whichever one works for you is wonderful.